Okay, so we're back today and we're going over the third section in this probability chapter. We are going to define and use probabilities. So we've kind of been talking about how to find sample spaces, how to count, different situations. Now we're going to apply that to probability. So you have that handout, that PDF. You can use that to take your notes, or you can just do it normally. You can just listen to if you want. So the first thing we have to define is what an outcome is. An outcome is a possible result. So you have something happen, and then, oh, well, if I flip a coin, I could have it land heads, I could have it land tails. Those are each outcomes. When I look at an outcome or a collection of outcomes, that's called an event. So if I'm looking at heads or tails, then that's an event. That is something that is happening, made up of multiple outcomes. Probability, this is important. It's a number from 0 to 1 when we talk about probability. So we can't have negatives. We can't have something happening more than once or happening more than one time, because we can also talk about it in terms of percentage. So we can't have it happen more than 100% of the time. Can't be negative percentages. And that indicates the likelihood that the event will occur. And as I've just kind of alluded to, we can talk about it from 0 to 1, but we can also talk about it in terms of fractions, decimals, or percents. Yes, you heard me right. This is a place where I am actually going to let you use decimals. A lot of times we like to deal with fractions because we can really see the different parts of the probability, different parts that make it up. That will make a little more sense in a minute. Percent is also a big one. Decimals work fine, but these are the two most common that you see out in the real world. Again, probability, as much as we hate the statistics and stuff that we're doing in this chapter, it is something that applies more to real life. Okay, so we should have all that down. Then the next part we're going to come to here, little study guide, theoretical probability. When all the outcomes are equally likely, the theoretical probability that event A will occur is the number of outcomes in A versus the total number of outcomes. So there's nothing tricky here. If you're tossing a coin, you could either get heads or tails. Well, as long as it's a fair coin, it's not weighted in some way, the probability of getting heads would be one way to get heads out of two outcomes. This is a pretty important idea here, that it's the total number of outcomes over, or the total number of success is another way to say that. So successful outcomes over the total number of outcomes. The ways to get what you're looking for over the total ways something's going to happen. Oh, didn't realize, of course, I had it down there. But go ahead and make sure you have that as well. All right, so a couple examples. Find the probabilities when rolling a 6-sided die. So just a normal die. And if we're doing this in class, we might have die out and we do some activities, but I'm not going to make you do that here. When rolling a 5, so if you roll a dice, how many 5 are on the die? Well, there's just one 5. How many sides does it have? 6. So you have 1 out of 6 ways of rolling a 5. To roll an even, well, even numbers, we would have 2, 4, or 6. So there's 3 ways to roll an even. There's still 6 total ways to roll the die. We always want to reduce, so we'd say 1/2. And again, you could use that as a decimal. You could say a percent, but the answers that I'm going to give you when we go over answers are going to be fractions. They're always going to be reduced. There may be some exceptions when those denominators get really big, and I'll try and indicate that on the problems. Next one here, and again, probably don't need to write this down, just kind of write along what I'm doing. A community center hosts a talent contest for local musicians. On a given evening, 7 musicians are scheduled to perform. The order in which musicians perform is randomly selected. So this idea of order, that's going to potentially bring in some ideas of what we were doing in the last couple sections with factorials, permutation, combinations. What is the probability that the musicians form in alphabetical order? Well, how can they perform in alphabetical order? They can only do that correctly one way. The tricky part is, how many ways can I get them to do this? Well, the order they're going to perform is important. They can't just say, oh, these 7 are going to perform out of 10. I want to know it's going to be musician 1, 2, 3, 4, or is it 2, 3, 4? So how many ways? So the order matters. Think about what that deals with. That deals with permutation. So I have 7 that I'm choosing from. All 7 are going to perform. Another way I could write that is if I do my blanks, if I have 7 of them, it would be 7, 6, 5, 4. It would be the same thing as 7 factorial. So that's either way to get your total. Well, once I do that, whichever way, I get 5,040. And there's only one way to do it correctly. So 1 out of 5,040. And again, if you want to change that to a decimal, you could. So now here comes the next part. You are friends with 4 musicians. What is the probability that the first 2 performers will both be your friends? Well, so again, we have to know the total and we have to figure out, okay, we've got your friends. So to be your friends, 4 are your friends, and we want to choose 2 to do that correctly. And then the total way to get that, we don't care who's first, who's second. There are 7, and you're just doing the first 2. You don't care about the rest of the order, just the first 2. So the reason I'm using combination here is I'm just looking at the first 2. I'm not saying, oh, they have to go first and second or second and third. So 4 friends, I'm choosing 2 of them to go first. 7 people, choosing 2 of them. So once I do those, I'm going to get 6 out of 21, and we always want to reduce. You have a 2 in 7 chance of seeing your 2 friends first. All right, so moving on to the next part, you are equally likely to choose an integer from 1 to 20. Whenever you see this, this also includes the 1 and the 20. We want to find the probability of picking. Let's start off with a perfect square. So we got to know our perfect squares. 1 is a perfect square, 4, 9, 16, 25, so it's not in our set. So there are 4 ways to have a perfect square. 1 to 20, there's going to be 20 numbers in there. Reduce, 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 1/5. And then a factor of 30. So factors has to go into 30. So we think about factors. I like to do them in pairs. So 1 and 15. Well, that's not right. How about 2 and 15? 1 and 30. 6 and 5. 3 and 10. I think I've got them all. 1, 2, 3, 4, 5, 6, 7, 8. And I would like to see this work here when you're figuring those things out. Write out at least the successes. When you have to use permutation and combinations, I do want to see what you're doing there as far as your work when you're turning this in. 1, 2, 3, 4. Oh, I got a little issue here. I was checking my work. 30 is not less than 20, so we have to go 7 out of 20, and that doesn't reduce. So 7/20 is my probability there. All right, so you often hear probability, but you often hear odds in real life. Odds is measures the chances in favor of an event occurring or the chances against. So favor and chances against an event occurring. Those are your 2 blanks there. So the odds in favor, the way we figure that out is we do the number of successes, not over the number of total now. Now it's over the number of failures or the number of ways you don't get it. Whereas the odds against something happening is just the reciprocal of that, where it flipped, the number of failures divided by the number of successes. So when we talk about odds, it is important to know whether we're talking about odds in favor, success over failure, odds against, failure over success. So back to that standard deck of cards, and it's always going to be a standard deck. I don't have any problems where I mix up what the deck looks like. So we want to find the odds in favor of drawing a 10. So if I was doing probability, it'd be 4 out of 52, but we're doing odds. So there's 4 ways. Then I have to figure out how many are not 10. So I subtract the 4 from the total. That would be 48. Of course, we always want to reduce. We have a 1 in 12 chance of drawing a 10. And that's how you can say odds. And that's why we often see odds a lot more. Think about lottery and things like that. That's what you're seeing a lot more than probability. Against drawing a club. So against drawing a club, we have to think how many are not clubs. So we have more likely of drawing not a club, 39. And clubs are 13. So we have a 3 in 1 chance of not drawing a club. And we can always go back for these and see if our answer makes sense. So against drawing a club, is it more likely not to draw a club? Yes, there's only 1 suit versus 3, so 3 out of 1, that makes sense. All right, last thing to talk about, experimental probability. We don't spend a lot of time on this because it's what actually happens, so we have to do experiments. Theoretical is great, it's what should happen in real life, but if you go and you flip a coin 50 times, you're probably not going to get 25 heads and 25 tails. You really have to have a lot of events to get it to be exactly 50-50. Most of the time. Of course, it can happen occasionally. So experimental is the number of trials that you have success versus the total number of trials. But again, we don't spend a lot of time with that. You may see a couple story problems with that. All right, so that wraps up our introduction to probability. And so again, you're going to that old PDF, and I will try and do what I've done and get that shortened down or shrunk PDF on Google Classroom for this, but it's on page 701. This is section 10.3. You're going to do 3 through 6, 10 through 18, 20 through 23, 28, and 29. And I will grade this the same way as a normal homework. 8 points for attempting it and showing your work. Think about what I talked about. Show your favors. Give me a little bit of thought process behind it. But you're going to show a little bit of work. There won't be a lot for most of these. Reduce your fractions, and then turn this in via email or Google Classroom. Personally, I prefer Google Classroom just because then everything's all in the same place. But really, either place is good. If you need help, let me know. Whether it's help with attaching that, help with any of the questions. And we are going to have a Google Meet on Tuesday. Look to your classroom for more information on that. That's just pretty much going to be for questions and stuff. And of course, as you're working, shoot me an email, send me something on chat, and I'll try and get back with you as soon as you can. I'm often near my computer, or we'll send you an email and say, hey, I'm going to check soon, or I'll be back at my computer at such and such time. All right, I certainly miss seeing all you guys. Hope you're doing well. I'll check in with you later.